graphs of inverse functions. So our objective here, use the graph of a one-to-one function to graph its inverse function. So we know a couple things coming in that are going to help us. We know what a function is. A function is a relation in which each component of the domain, each input, each x value, corresponds to exactly one component of the range, output value, y value. If it's a function, the graph will pass the vertical line test. And we also learned in a previous video what a one-to-one function is. It's a special type of function in which each component of the range, each output value, each y value, corresponds to exactly one component of the domain, input value or x value. In other words, the outputs never repeat, okay? And we learned that graphs of one-to-one functions pass both the vertical line test. Okay, it can't be a function. It has to pass the vertical line test to be a function. But to be a one-to-one function, it has to pass that for a function and the horizontal line test. Okay, so we have a second test to determine whether it is a one-to-one function or not. So, if a function is one-to-one, its inverse has ordered pairs with its coordinates switched. Okay? When this is the case, the graph of the inverse is simply symmetrical or reflective about the line y equals x. So fairly easy to graph a one-to-one function using this property that it is symmetric about the line y equals x, and the ordered pairs are simply switched. Let's take a look. I think you'll find this to be fairly straightforward. Okay, so here is, use the graph of f. Well, we're told f is a one-to-one function, okay, which means f has an inverse. Okay, I want to draw the graph of its inverse. Well, all we need to do is reverse the coordinates for the inverse. So if f is 4, 2, well, we'll switch these. 2, 4 goes on the graph of its inverse. If the f function is at -1, 0, we'll switch these, go to 0, -1, and that is on the graph of the inverse. If f's function goes through -3, 2, we'll switch them, which means -2, 3 is here, and that is on the graph of its inverse. Finally, I'm going to look at, leave those 3 points. Now let's also use, sorry, I got myself a bit confused. Let's also use the line y equals x. Okay, well that line goes through here, 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 here. So here's the line y equals x. And we know that the graph of the inverse is symmetric, so I'll kind of go on down like this. And this is the line y equals x. And you can see it's symmetrical, symmetrical, symmetrical. It's reflected about that line. And of course, it crosses the line right here, so that point is on both graphs. Okay, so here is our inverse function right there. And this is, so if this one is y equals f of x, then, so I can't draw it, this one is y equals f inverse of x. Okay, so the graph of the inverse of a one-to-one function simply requires that you switch the coordinates, and then you can draw the line y equals x and make sure it is symmetric about that line. It reflects about the line y equals x.